A very good evening, everyone. I am Sushmita and I will be your anchor for this winter school training program. On behalf of Vital Biotech Agriculture Forum for Technical Education of Farming Society Kota, Indira Gandhi Krishi Vishwavidyalaya Raipur, University of Agriculture Agricultural and Modern Science Innovations. Vital Biotech is India's leading publication, research, and training institute whose goal is to tackle the world's most pressing problems related to food and agriculture. Whereas the Agriculture Forum for Technical Education of Farming Society, Kota, serves as a spiracle between the network of rural communities in India and other stakeholders such as government, development organization, and corporate entities. Indira Gandhi Krishi Vishwavidyalaya, IGKV Raipur, Chhattisgarh, was established on January 20, 1987. IGKV has a primary mandate to provide education, conduct research, and offer extension services in the field of agriculture and related areas. Its work plays a vital role in improving agricultural practices and the lives of farmers in Chhattisgarh. University of Agricultural Sciences Raichur came into existence on 22nd November 2008 through bifurcation from USA Dharwad. It is the third agricultural university established in the state after Bengaluru and Dharwad in Karnataka. With the establishment of USA Dharwad in 1986, Raichur still had the privilege of being the second largest campus and a major hub of education in this region. Atal Bihari Vajpayee Vishwavidyalaya, established in June 2012, has nearly 95 government and private colleges affiliated in four districts of Chhattisgarh state, which together constitute the jurisdiction of ABVV. The university plans to develop a strategy for enhancing the range of educational approaches and the use of technology. As a part of this approach, the university plans to start classroom into state-of-the-art ones, enabling teachers to teach using a wide variety of media. Farmers Park is a platform committed to empowering organic and natural farmers across India by providing farm advisory services, free soil testing, and marketing support. It aims to promote sustainable farming practices, helping farmers maximize their yield while protecting the environment. Through their services, they strive to create a strong, eco conscious agricultural community nationwide. This evening, we are indeed fortunate to have such honorable dignitary among us. It is my privilege to introduce Dr. Amresh Y.S. Sir. Sir, currently working as a Chief Scientific Officer and Professor of Plant Pathology at the Director of Research, University of Agricultural Sciences, USA, Raichur, Karnataka. With over 24 years of professional experience in teaching, research, extension, and administration, he has held various significant roles, including senior scientist, assistant professor, and research associate across reputed institutions. Dr. Amresh did his BSc in agriculture from the College of Agriculture, Raichur, and earned his MSc and PhD in plant pathology from USA Dharwad. In his teaching career, Dr. Amresh has offered undergraduate and postgraduate courses in plant pathology and has guided 17 MSc and 4
I
PhD
joined, sir.
students.
I joined. Yeah. Oh, huh.
As a researcher, he has led over 10 projects as principal investigator with a combined budget of 5 crore and contributed as a co-PI to 20 additional projects. He has been instrumental in developing and distributing 27 technologies to benefit farmers in the Kalyan Karnataka region and has organized several training courses for extension personnel. Dr. Amresh has been recognized for his contributions with numerous accolades, including the Fellow of Indian Phytopathological Society in 2024, Best Scientist of the Year Award in 2023, and several gold medals for academic brilliance during his postgraduate studies. He has an extensive publication record with 185 research papers, 9 books, 8 book chapters, and numerous other contributions through conferences, radio talks, and television programs. His dedication and impact in the field of agricultural sciences underscore his significant role in advancing plant pathology research and education. Respected sir, your achievements are immense and it is difficult to encompass them in words. So, without further ado, I warmly welcome you and gratefully hand over this winter school virtual stage to you. Over to you, sir.
Thank you, madam. Thank you for your nice introduction. Are you hearing my voice? Is it?
Yes.
Yeah.
Yes, sir.
Audible, sir. Audible.
Oh, it. Then no problem, sir. Yeah. Can you share, sir, my slide?
Yes, sir.
So, respected participants and organizer, I once again thanks the organizer for giving me opportunity to share my experience with the uh, various scientists across the country. Uh, for that, once again, I thankful for the organizer for giving an opportunity to share my views. Then come to the today, sir, first slide. So can I start now, sir? Yeah. Is it audible? No, no problem, no?
Audible, sir. Audible.
Yeah,
Please
yeah.
start.
I'll start my presentation. For this 21 days training program, I have been selected, chose the topic as a role of bioagent, in plant disease management for sustainability of agriculture. You know that. Next slide, sir. Next slide. So you know the no doubt in India we have achieved the green revolution. We have self-sufficient in the production. We already after the independent we have the several revolution. That cereal-based green revolution. We have white revolutions. Now, that will not retain for the longer time. And now even we are facing the nutritional security, and that is a hidden hungry. This is the one of the biggest challenge of Indian agriculture at present situation. And we have another challenge is to meet the globalization. That is a to Indian agriculture produce should be substantially to meet the world global trade. And another challenge in Indian agriculture is the climate change. Recent year we have seen the impact of the climate change, and also other things and diversity, and even the development biotypes and the emergence of the many pests and diseases. All these are challenges in the Indian agriculture. They will take our food, and you have to think and research. You have to continue the research and to overcome all these challenges. We have many opportunity or many ways among the next slide, sir. Next slide. So among the various opportunity are the ways to in order to meet these the challenges, new challenges in Indian agriculture, there is a scope, and we have one solution, that is a organic farming or the eco-friendly management of the plant diseases. In this regards, let us discuss some about the organic farming. So you know that already many of the participants are aware of the organic farm. Just for your, I will recollect your memory. Organic farming is nothing but it is a defined as ecologically, economically, socially responsibility way to farming to provide the enduring supply of the safe and healthy food and fiber production, with a possible of least possible losses of the nutrient and energy and least negative impact on the environment and ecology. This is given by some scientists. Next slide, sir. So these are the component of the organic farm. So we know already that is a way to meet this nutrient by through organic compost, waste, green manure crops, and the nutrient requirement of the crop can be met with through organics. And next option is the plant protection. So in order to meet organically plant protection, we have the one option is the bioagents. A different method. So let us see next slide, sir. Let next slides. Next. Just before going for the bioagent in plant disease management, let us just to view the growth of organic agriculture in India. This is the recent year in globally the importance of organic agriculture is gaining. And nowadays at present we have the by end up to 2020, just we reached the 1.5% of the world land agriculture is converted into organic agriculture. Next slide, sir. Let me come to the next slide. So this is the percentage distribution of organic agriculture land worldwide, and there is a lot of scope is there. India having only the limited area. Next slide. And this is the just the during the 2020-22 the organic area in India, it has been increased substantially among the different states. Among the different, Chhattisgarh is the leading state in organic agriculture. It was reached about the 3 million hectares, followed by Madhya Pradesh, Maharashtra, Rajasthan, even Karnataka having its own area on agriculture, organic agriculture. Next slides. Next slide. Then again, this area, the organic farming in India is much more increasing year-wise, year after year. That is because of the government policy. The central sector sponsored one project. There are different projects, but among the one project, the PKVY, the Paramparika Krishi Vikasa Yojana. This is the center sector plan or program. It has been helpful in promoting the organic farming, and it has some its component, and it will it will give the financial support to the farmers, and in individual and also in cluster approach. And even every farmer under this project, he will get the 20,000 rupees per acre as a financial benefits, and it will create a better linkage in market and also certification of organic product. Next slides. And these are the table or this picture shows the state-wise major crops grown under the organic farming in India. And in Karnataka, we have the rice, rain-fed wheat, maize, sorghum, pulse, oilseeds, and some of the vegetables are grown organically, and it was marketed. Next slides. And it is in India that in the organic the plant diseases, already plant diseases are plays important role in reducing the yield losses in various crop. And earlier we depends upon the many chemicals, many fungicides, but because of the toxicity, other reasons, and the development resistance strains in various pathogen, and also having the environmental pollution. Recently, we have the in the organic farming concept and the bioagents, the management of plant disease. Bioagents are the plant growth promoting rhizobacter, or the bioagents are now recent year it has gained much attention to the researcher and also among the farmers, and farmers also preferring bioagent management of plant disease. And why recent year this bioagent were gaining most important means these are the reason. One is the safe and eco-friendly, and also need-based choice compatible with the insecticides and fungicides, formulation shelf lives we have, and to even combat the development of strains also we can reduce with the help of this bioagent. Next slide, sir. Then recent year, several pest and pathogens are resistance to the pesticides have been reported to in order to avoid or minimize. The best option is biological control or the bioagents, and degradation of natural element because of the heavy toxic elements, heavy toxic fungicides. There is a natural enemies were reducing, and at the same time there is an outbreak of the minor pathogen or pest, and also that is a environment pollution and risk cost of input, and also plant protection, and another the residual toxicities nowadays in the international market. Indian produce was rejecting it many times because of the residual toxicity of the retention of the many toxic fungicides, pesticides in various product in the market or in the international market. It was there is a they required the disease that residual free product. So these are the reason recent year the biocontrol plant disease management is gaining much important. Next slide, sir. Then when you take any handful of soil, it is this handful of soil contains the numerous microflora, and most of the microflora which are there in the environment or in as our soil is most beneficial only, and only 1 or 2% were causing the plant disease. By to eliminate or to manage the 2% or 1% of the microflora, we are dumping the large quantity of the fungicides, chemical pesticides on soil, and by this way we have reduced the beneficial flora fauna of our soil. Now we have to think in enhancing this flora or the beneficial flora in this soil. Next slide. Next, our soil. Next slide. Next slide, sir. Next slide. So the in order to in the bioagent, the most widely and the potential bioagent is the fungal bioagent, that is a trichoderma. And recently it has been commercially utilized in India against the various plant disease management, and presently it is a present in all the Indian soils, and many species are the trichoderma are used in plant disease. Next slide, sir. Let us see first study some light on the trichoderma, then we'll move to the pseudomonas. And this fungus, this is soil-borne soil-based fungicides, fungus. It is a belong to the phylum Ascomycota and the Hypocreas, and the genus is Trichoderma, and it has a first is Hypocrea. Next slide, sir. And these some of the trichoderma species which are widely used in plant disease management are the Trichoderma urzianum, Trichoderma viridae, Trichoderma virescens, ameta, and these bioagent, trichoderma bioagent can be culture morphologically we can identify based on the colony color, branching habits, and also the formation of pellets and the spores. One can easily identify and make use in the plant disease management. Next slide. These are the worldwide the phylogenetic tree of the trichoderma. These are the some of the species which worldwide have identified, and they are used in plant disease management. This is the key phylogenetic tree of the trichoderma species worldwide. Next slide, sir. Next slide, sir. Next slide, sir. Next slide, sir. Sir, next slide. Sir, are you hearing, sir, my voice? Hello?
Yes, sir.
Sir, next slide. Next slide.
This is the next, this one.
Next, phylogen, next slide, sir.
Which one, sir?
Yeah. So this, okay, sir, wait. So in our agricultural university, we have established a biocontrol lab, and this lab was initiated the isolation, and they're working on the bio isolation of this trichodoma, and we have isolated the native trichodoma species in northern Karnataka of the Karnataka in Karnataka state in different ecosystem, the chili ecosystem, cotton ecosystem, pigeon pea ecosystem, sorghum ecosystem, like this in many different soil ecosystem we have isolated and we have identified, and many of the research students are working on this trichodoma. And this is the slide showing the testing of the trichodoma version against the sclerotial plant disease. It causing the root rot in many crops, and we have isolated the different strains of trichodoma, and we have tested in laboratory condition against this sclerotia. Next slide, sir. Similarly, we have tested this isolated trichodoma against the alternaria. The slide was showing the efficacy of the trichodoma species against the alternaria, which causing the foliar diseases in various agriculture crop. Next slide, sir. And similarly, again, these good number of bioagents were also subjected to the another soil-borne plant pathogen, that Aspergillus, and we also identify the trichodoma species against Aspergillus also. Next slide, sir. Next slide. So again, another soil-borne pathogen, rhizoctonia, which causes the root rot and seedling rot in various crop, pigeon pea, chili, other various crop. We also isolated these trichodoma, and we tested against this rhizoctonia also. Next slide, sir. And these are some of the effective trichodoma species we identified. Next slide, sir. This show, and we have genetically characterized and molecular identified. These are the trichodoma viridae at Raichur isol 7. These are the isolates having the effective against all 5 to 6 soil-borne pathogens, and we identified the morphologically and also genetically. These are the strains which we deposited also in gene bank. Next slide, sir. These are some of the isolates from our region in North Karnataka. Again, in the various plant ecosystem we isolated, and we have tested against various 5 to 6 soil-borne pathogens. They are found effective, and we have identified and we deposit. These are the action number of these trichodoma bioagent in bank. Next slide, sir. And also, not only we have identified and we have tested the viability of this trichodroma isolate, effective isolate at various temperature and also pH level also. Some of the isolates, they have shown the viable even at 30 temperature and radial growth. The above 40 degree, there is a affect the growth of these bioagents, and also pH 7 to 9, even 11. Also, we find certain growth in these bioagents. Hence, these are also adapted. That shows the wider adaptability in various soils. Next slide, sir. And even we also tested this bioagent, trichodroma bioagent, to against the various fungicides, insecticides, and herbicides, which generally the farmers were using in our region in northern Karnataka. In case of fungicides, we tested the various fungicides for its compatibility with the trichodroma species, and the metaloxyl and few fungicides are shown the compatible tricyclosan. Rest are they are not the compatible. percent inhibition is there. Similarly, the imidazole and also chlorothalonil, and also these insecticides are having the compatible, and the most of the herbicides generally 2,4-D, pentamethylene, and also ammonium salts, glyphosate, Vitaclor, they are compatible. They don't find any inhibition of this trichoderma at laboratory conditions. And that's next slide, sir. Again, the Viridae, we have tested against different isolates, Viridae, Trichorhizium. Next slide, sir. Next, same trend we have seen in Ameta, Viridae also. Next slide. And again, we have seen the effect of, we also study has conducted to say the effect of seed treatment of these bioagents on different crop growth. We tested against in pigeon pea and chickpea, and just seed biopriming, seed coating of these bioagents, trichoderma species, that has shown there is a enhanced the seedling vigor, root length, shoot length, and also controlling the plant diseases compared to the control. Just you can see it clearly shows that there is a this trichoderma not only protecting the plant diseases from plant pathogen, it also enhances the plant growth. Plant growth we can see by this table. Next slide. Similarly, this again against the Trichoderma hamata and green gram and black. This slide shows the growth of the green gram and black gram. By just seed priming, we can enhance the growth of these green gram and black gram. You can see the root length and shoot length elongation also. Next slide. Then once we have identified, we have isolated, and we identified the effective trichoderma species from our zone, our region, and we also tested against their compatibility with the insecticides, fungicides, and herbicides, and also we tested their survival with the survivability in different temperature level and also the pH level, and which for effective one we have now mass multiplying with the top based formulations, and we are supplying to the way farmers as a top based trichoderma bioagent. Next slides. So even we study the shelf life and other formulations. Just next slides. And this is the map showing the worldwide usage of this trichoderma in various the agriculture product as a bioagent or biopesticides in different countries we are using as a bioagent, as a trichoderma. Next slide, sir. And I can come to the method of application. Generally, we recommend as a seed treatment, 5 to 10 grams of bioagents per kg of seeds, it generally. And in addition to that, again, it can be enriched with the FOM or even in soil application also. Enriched application we recommend from our university, we recommend 2 to 3 kg trichoderma is mixed with 100 kg of the FOM and incubate the 5 to 10 to 15 days. Then you can apply to the soil. And even set in case of sugarcane, it is also advised as a set treatment or even planting material seedling also in vegetable crop also. Next slide, sir. So these are some of the registered bioagent trichoderma product which have been registered and which is available in Indian market. And this the first collection, Trichoderma arizianum. This was available as a Biotech, different companies for another Trichoderma arizianum. It is available as a root shield and plant shield, like this. These are some of the commercially product which are available in Indian market. Next slide, sir. So we have the more than 30 commercial products are available, which are registered in India in CIB registration process. These are the some of the trichodroma commercially available product which are registered in India. Next slide, sir. Again, we have used in this trichodroma as a effective bio waste management, and we tried in mixing with the different the image and different byproducts. Byproduct of our agriculture, that's a rice husk, sawdust, groundnut cake, castor cake also, and it was available, and it can survival even the more than 100 days. 100 days. Next slides. Next slides. Same in different species, and even not only managed the fungal disease, even we have it is recommended to manage the nematode disease also. In case of tomato and even in pigeon pea, we have the complex, the root knot and fusarium wilt complex. For that, this trichodroma has shown very effective as a seed treatment and soil application. As shown, we conduct an experiment. Next slide, sir. It has shown that the soil application of this trichodroma and seed treatment has given the good result compared to other treatment. As next slide, sir. This is the photograph showing the seed treatment in tomato. It will manage the wilt as well as the root knot nematodes. Next slide, sir. This again, we used the trichodroma species with the different bioagent, and see the growth of Rhizoctonia bataticola has reduced in various bioagents, Trichodroma viridae, aspergillum, and all arisum. There is a drastic reduction of the fungal pathogen. Next slide, sir. Again, the amending with the different organic product, the trichodroma amended with the neem cake, and trichodroma amended with the mustard cake, and trichodroma neem cake has found better in growth of this bioagent, and also there is a reduction of the disease also. It can be used alone or in combination with and this the result shows that there is a instead of alone application, you can mix with some of the organic amendment, and that will enhances the reduction in the disease, and survival of this bioagent is better, and also it reduces the many soil-borne diseases in various crops. Next slide. Next slide. Same thing, sir, with the mung bean. It has seen the growth parameter, and where it has enhanced the root line, shoot line, pod, and under seed weight also. Next slide. Next slide, sir. It is seen in chickpea against the chickpea, dry root causing dry root rot in chickpea. So the how this so it is a curative control plant pathogen by extra of the toxins. Sorry, next slide, sir. Next plant extract application. Next slide, sir. So the some of the even the plant products in organic concept, even plant products also used against the to manage or to use in plant disease management. This is the list of the fungicidal property of the plants which are seen in, which are available in acacia, datura, and these pomegranate extract, eucalyptus plant product, extract can be used against aspergillus, various species of aspergillus, even eucalyptus has shown the effect against alternaria, even neem, garlic extract, turmeric extract is also shown effective against the Fusarium oxysporum. Next slide, sir. even in case of organic, we have the Panchagavya. Panchagavya is one of the most used organic weapon against the plant diseases, and this contains the different component of this cow dung, cow urine, water, cow milk, and this can be jaggery. And this Panchagavya is used in plant disease management also in organic. Next slide. Again, we have the Bijamrita, another the organic product which used in plant disease management is the Bijamrita. Bijamrita, and it is again the mixture of the garlic extract, milk, cow dung, beef extract, and cow urine, cow dung. All these mixed, and this is used against the many of the seed borne diseases can be managed by seed treating with this Bijamrita. We can reduce the incidence of many seed-related plant pathogens like Rhizoctonia, Fusarium, even downy mildew pathogen. Even in case of blast of paddy, periphery also managed by treating with this Bijamrita. Next slides. The management, even the powder mildew also, we can manage through the organic products, plant extract, trichoderma, even the Bija Jivamrita. Next slide, sir. Next slide. And these are the this table has shown the efficacy of some of the organic products which are used in pango management of powder mildew, management of the mango powder mildew, the cow urine, Jivamrita, Bijamrita, and the extract. Next slide. Again, this is also some of the commercially, even recent year in market also it's available as a organic product like neem based product, other plant extract, or even the other seed weed extract also. There are good number of commercial products are available in market. All are also found to be, we have tested different product. They are also on par with the fungicides. They are reducing many diseases, even in Biotech, rust disease also, powder mildew also, leaf spots also. Next, various disease management we can make use, or we can use these are commercially available organic plant products. Next slide, sir. Next slide. The same things. So in the sustainable production, the sayings from our great scientist Swaminathan, that's the indiscriminate use of pesticide, fungicides, herbicides could causes adverse changes in the biological balance, and that leads to the increase in the incidence of many not only plant disease, even the human diseases also. And through these toxic residues present in the grains and other part of the agriculture product. So therefore, there is a need to initiate exploit the agriculture without proper understanding the various consequences of that product chemicals, and the Biogen having the one of the solution to overcome all these the problems. Next slide, sir. So thank you for thank you, sir. So any questions? Next.
Thank you, sir, for taking the time to share your insights on such an important and valuable topic, the role of bioagents in plant disease management for the sustainability of agriculture, covering in detail organic farming status, policies promoting organic farming like PKVY, plant growth promoting rhizobacterium, biocontrol, Panchagavya, Bijamrit, etc. Thank you, sir. I would like to invite our participants to ask any queries.
Thank you.
Chat box is on now. You can ask. if anybody want to ask.
Sir, there is a question from
Yes, sir.
Shivam Kumar Lal.
Yeah.
Can we
Sir,
use the
that the GMO crop, the genetically modified crop, is not included as a organic, organic agriculture, uh, because it may be included some exotic uh, microflora, biogen, like so. That is not in considered as organic GMO cross. You have to isolate, and you can modify our biogen strain. That is also okay. You can incorporate our strain. Suppose the Pseudomonas or the Bacillus thuringiensis, BT cotton, but it is only for the plant disease management, one of the component, and it is not considered as organically.
Subhash, you can ask. You can unmute yourself. Subhash
Yes,
B.
good evening, sir.
Yeah.
Sir, actually, in my research trial, I have initiated. I'm working on chickpea, and at the time of sowing, I have treated all those chickpeas with Rhizobium astrobacter, sir.
Okay.
But the
Fine.
but the thing is, after initiating these biocontrol
But,
agents, I could able to identify more infestation of those root knot nematodes in my treatment field, sir.
okay. So by
So what
treating,
could maybe
you
the
have
solution?
included as a some of Trichoderma pseudomonas as a say treatment along with the biofertilizer.
No, sir. I have induced only biofertilizers, sir.
Biofertilizers.
I have
Biofertilizer is
induced the
mainly
biofertilizers, and also I have induced as a stress hormones materials such as weed extracts and some of the
okay.
micro and macronutrients,
So
sir,
you are
as a foliar
concentrating
strain I
only
given it.
on the nutrient aspects,
Yeah,
not.
yes, sir.
So please, you can include the bioagent like Trichoderma pseudomonas that will uh, combat in the plant disease management, particularly the wilt and nematode.
Yes, sir.
Just for the plant disease, wherever the problem is there in your experiment plot, just
Yes,
or generalize, you can treat the Trichoderma as a common treatment, and you can come out from this the wilt management.
yes, sir.
So there
Thank
are
you, sir.
some few questions from HR Dhanetia. What about the efficacy of Bavaria bassiana fungus against termite?
Termite. So Bavaria is against some of the insect pest, but on the termite, I think we have to test that, conduct experiment, and so far we don't conduct any experiment on the termites, mainly termites.
Sir, there is a question from Shaikh. As neem cakes has an antagonistic effect on fungi, can you
Yeah.
please suggest how trichoderma compatible with neem cake?
So even the trichoderma as a neem cake, it acts as a for nutrient initial period. It serves as a nutrient source for the nutrient, and the trichoderma will multiply, and it provides the condition for the multiplication, and it will again in turn after multiplication it will suppress the plant diseases. We have experimentally conducted, but with some proportionate, we have to mix it, not 100% neem cake. So you have to mix with organic amine FOM and some part of trichoderma, then the neem cake, not alone neem cake. Neem cake has some inhibition effect on fungal.
Thank you, sir.
Shivam Kumar Lal, you can unmute yourself.
Thank you, sir. Good afternoon, sir. Sir, actually, I have question regarding the GMO crop. As I am not satisfied by your answer previously, Sir, how GMO crops are not prescribed or simply not taken as an organic
No, just on the
crops or
basis of
organic
the
farming?
BT. BT is a GM crop, no? BT cotton. Most
Yes.
of our cotton area is replaced by GM crops, that BT cotton. And in organic concept and principle, we are not considered as a BT variety or BT cotton as a organically. And this many concepts, many scientists are not accepting this. So on this basis, so I answer your question. Even next brinjal GM crop is also ready, but the government has not given the permission. There are some issues. Okay.
Sir, but these GM crops are not allow for the other agriculture, not only for the organic. But
It has
if we
a
talk about
no. These GM crops have some other negative effect on the our native flora and fauna. In this, there is some issues. That's why the government has not allowed. Only the BT cotton is allowed, and in India, the most of area cotton area is replaced by BT cotton only. BT cotton only. But BT cotton is not considered as an organic product in India. And it is one of the IPM component. BT cotton is one of the IPM component in manage the ballworm complex. We have single BT, double BT, and again we have one more BT also added in the cotton varieties.
okay, so you mean that in organic farming we can't use the
Yes,
uh,
yes,
GMO
yes.
crops?
Yeah.
Okay, thank you, sir.
Thank you, sir. Thank you for engaging in this insightful presentation as well as for addressing all the participants' queries. I am confident that the participants have greatly benefited from your extensive expertise. We sincerely appreciate your willingness to share your profound knowledge with us. Wishing you continued success in your path. Thank you once again, sir.
Thank you, Madam, for giving my opportunity to share my views with various parts. Thank you, one and all.
Thank you, sir.
Thank you.
You, sir. Our second distinguished speaker is Dr. Vista, the Chief of the National Soil Research Center, NARC, Nepal. He coordinates overall soil science research in Nepal. Sir has done MSc and PhD in agricultural chemistry and soil science from Bidhan Chandra Krishi Vishwavidyalaya, Mohanpur, West Bengal, India. He is an expert in digital soil mapping, soil fertility, and nutrient management, soil pollution and environment, soil organic matter, soil carbon, soil health management, biochar production, and management are the expertise of Sir. Sir has published more than 75 research papers, 11 books, 19 book chapters, and he is the member of editorial board of 13 reputed journals. Sir is also an adjunct professor at the Himalayan College of Agricultural Sciences and Technology, Purbanchal University, Nepal, the Institute of Agriculture and Animal Sciences, Tribhuvan University, Kathmandu, Nepal. Dr. Vista is an international visiting professor at Shobhit University, Meerut, India. He is the focal person at Nepal Seed and Fertilizer Project, which is funded by USAID and implemented through CIMMYT Nepal. Sir is General Secretary and life member of Nepali Society of Soil Science. Dr. Vista is the regional coordinator of Asia Impact Youth Sustainability and coordinator of International Association for Promoting Geoethics Nepal section. Sir is also a life member of the Society of Agricultural Scientists Nepal. Sir is an awardee of Global Soil Scientist Award, Most Outstanding Principal Investigator Award, and many more significant awards. Sir, your outstanding accomplishments are truly inspiring, and it would be impossible to capture them all in such a short period. With utmost respect, I warmly welcome you and happily hand over this virtual stage to you. Over to you, sir.
So now I'm sharing. Everyone, namaskar, and a
Namaskar,
very good
sir.
evening to everyone. So can you see my
Yes, sir.
slides? So generally welcome everyone to the 9th day of the 21 days winter school training on fostering environmental sustainability through food security, agricultural and modern science innovations. So today I'll be talking not about the soil research, but I'll be talking something related with the soil science. As I'm a soil scientist, I'll be talking more on soil, and the topic which I choose today for deliberation is the power of the soil, advancing agriculture and sustainability through soil science. So it's not a research paper, but it advocates that soil is very important for agricultural sustainability, for environmental sustainability, and for food security, agricultural and modern science innovations. So to begin with, I'm sharing you the outline of my presentations. I'll be talking on the importance of soil, soil and agriculture. Then I'll be talking something about the sustainability and environmental health and innovations in soil science. Then I'll be talking on food security through soil management. Then I'll present some of the case studies, some success stories of soil science in Nepal. Then I'll try to give some of the future directions. What should we do? Then I'll summarize my presentations. So let me start with my presentation, the importance of soil. So everyone, we are quite aware that soil is the foundation of all forms of life on earth. So I generally say soil is life, and that is why there is no life without soil and no soil without life. So it has a very, interrelationship between soil and life. So even you can see so many, uh, religious mythological aspects as well, because in every mythology, we our life, it starts from soil. So the first form of life, it was developed in soil as well. So soil is life and life is soil. I generally used to say like that. So in every the constitution of almost all, in every countries, it is the constitution has guaranteed that every citizen should have the right to clean environment. So clean environment, what we generally say is clean environment, it comprises of healthy soil, clean water and fresh air. So healthy soil, healthy water, healthy air, it leads to healthy life. So every citizen has the right to live very healthily or to live in a very clean environment. When we see the civilization as well, we can't imagine any healthy civilization without healthy soil. Healthy soil is, is prerequisite for healthy environment, for healthy life. So healthy soil, it has a very important role in in achieving the sustainable development goal. It directly contributes to 8 sustainable development goals, and it indirectly it contributes 5. So out of 17 total sustainable development goals, directly and indirectly, 13 sustainable development goals can be contributed through soil science. So, these days, the soil science has emerged, or the soil has emerged as as a solution to the most of the global challenges. Now, I'll be talking on the importance of soil. Soil, as I already said, is the foundation for agriculture and ecosystems. Soil is the foundation for agriculture and ecosystems. As I said, it contributes to nutrient availability. It supplies essential minerals like nitrogen, phosphorus, potash for the crop growth, and also it also helps in the water retention. It acts as a reservoir. It helps. It is is a natural filter. It helps in storing water for plants during dry periods. It also uh, promotes biodiversity. It supports a very rich ecosystem for microbes, fungi, as well as insects and essential that are very good source for the soil for improving the soil fertility. So most often the food soil contributes to food security as well as for the human survival as well. Here there is one in the right side. I have shown in my slide that just a minute. Okay. I can't see myself. So, just a minute. Can I? There is some problem here. Anyway, no. Sorry, I can't see the slides. So in the right side, you can see that soil is central to all the global challenges. You see the food security, energy sustainability, ecosystem service delivery, biodiversity, climate change, water scarcity. These are some of the global problems. So these problems, this can be addressed by healthy soil. Generally, what we say, it plays a very good role in mitigating climate change, in achieving the food security. Soil can play a very crucial role in addressing several global challenges because it directly influences food production, water quality, climate regulations, as well as biodiversity. In the case of food security, healthy soil, it provides essential nutrients to the crops, ensuring better yields and sustainable agriculture. By providing or preventing the soil degradation and improving soil fertility, we can meet the growing demand of the food for the global populations. So, in case of climate change, what we say, soil acts as a carbon sink, as a major carbon sink that store more carbon than the atmosphere and vegetation combined. So practices like regenerative agriculture, no-till farming, and planting cover crops, this can increase soil's ability to capture and store carbon and helping mitigate the climate change. So in case of water management or water scarcity, healthy soil, it improves the water retention and also reduces runoff, and it prevents floods and droughts. It filters pollutants. As I said, it is the soil is the natural filter. So all the rainwater, it passes through soil, and that uh, the soil, the water in the groundwater, it can be recharged and reused. If the soil is not healthy enough, if it is polluted, in that case, the groundwater cannot be utilized even for the agricultural purpose. So, it plays a very good role in achieving water security. So, it filters pollutants. It also ensuring the cleaner water for ecosystem and human consumptions as well. So, in case of biodiversity, soil is the home to billion of microorganisms and small creatures that forms the foundation of ecosystem. So protecting soil biodiversity, it supports the health of the plant, animals, and the entire ecosystem. Also, soil can also recycle organic waste, turning it into nutrient through processes like composting. This reduces the burden of the landfills and also provide natural field fertilizers for the agriculture. So soil conservation efforts, I'll be talking more on that, such as reforestation and sustainable grazing. It can prevent land from turning into deserts. This also, helps to protect the livelihoods and habitats in arid as well as semi-arid regions. And also, when we talk about the public health, healthy soil can reduce dust storms and also the pollutants which can cause respiratory and other health issues. It ensures safer food by minimizing the contaminants that is absorbed by the plants. So what we can do, we can promote sustainable agriculture, like use techniques that maintain soil fertility and reduce the erosion. We can also prevent soil pollution, limiting the use of chemicals and industrial waste that harm the soil health. We can support soil research and education that encourage innovations and awareness about the soil's importance. So soil, it plays a very crucial role in addressing several global challenges, and some of which soil can be the solution. I just said that it helps in climate change mitigation. One is carbon sequestration, as I said. Healthy soil, it acts as a carbon sinks, sequestering carbon dioxide from the atmosphere. Practices, as I said earlier as well, such as agroforestry, cover cropping, no-till, it enhances the soil carbon storage, mitigating the climate change. So when we talk about the biodiversity conservation, because soil is the habitat for the microorganisms, soil is a home to diverse range of microorganisms, including bacteria, nematodes, fungi as well. These microorganisms play a vital role in nutrient cycling and maintaining the soil health. When we talk about the soil water conservation, water filtration is another part. Soil acts as a natural filter that removes pollutants and impurities from the water as it pass through it, and it protecting and maintaining soil health. It contributes to clean and safe water resources. So another aspect is the food security, and that is through the nutrient cycling. Healthy soil, it supports nutrient cycling, providing essential elements for the plant growth. Sustainable agricultural practices such as crop rotation and organic farming help maintaining the soil fertility, ensuring long-term food security. So another part is the land degradation prevention. Yeah, that is about the erosion control. Soil erosion is a significant global challenge. Vegetative cover and conservation practices help to prevent soil erosion, preserving the arable land and reducing the loss of fertile topsoil. So water management is another part where retention and drainage, these are some of the issues which we have to think about. It depends on the structure of the soil. Well-structured soil can retain water during dry periods and facilitate drainage during heavy rainfall. That contributes to effective water management in agriculture and reducing the risk of flood as well as drought. So the renewable energy is another part where we generally say bioenergy productions. So bioenergy productions, like certain crops such as switchgrass as well as miscanthus, this can be grown on the marginal lands to produce bioenergy that can provide a renewable source of energy without competing with the fruit crops. And also in the waste management, composting is one of the part where we generally go. And even these days, we are more focused on biochar as well. So composting, when soil can be a part of the waste management strategy through composting. Composting organic waste enhances soil fertility and structure, while reducing the need for chemical, fertilizers. So when we talk about the climate change, in order to mitigate the climate change, we also focus on, biochar. So biochar is another part where, we generally pyrolyze the raw material carbon, and that is used as a biochar, as a soil amendment. So in order to mitigate the climate change, in order to address those issues of climate change, we generally go for biochar, and that is also one of the options for waste management, biochar. So when we talk about the medicinal resources, in that case, microbial and fungal products, soil is, is a rich source of microorganisms and fungi that produce antibiotics as well as other medicinal compounds. So studying soil biodiversity can lead to the discovery of new pharmaceuticals as well. So when we generally go for community development as well, as because local agriculture encouraging those uh, uh, sustainable and regenerative agricultural practices at the community level can also enhance the local food production that can improve the livelihood and strengthen resilience to environmental changes. So to maximize the positive impact of soil as a solution to global challenges, it is very much essential to adopt some of the sustainable land management practices that promoting those conservation efforts and raising awareness about the importance of soil health among the policymakers, farmers, and general public. So when we talk about the soil and agriculture, we already know that soil, it supports plant growth, that anchors roots, and it supplies nutrients and water, that regulates water as well. Soil regulates the water, it filters and stores water, as I said, and it also recycles the nutrients. So it breaks down organic matter, and also it goes on, the process of mineralization and others, it goes on continuously in the soil. And it is habitat for not only for the microorganisms, but for all the life on earth. So this is habitat for all. Soil is habitat for all, and we should always respect soil. So soil is is beyond our thought. So what we generally think in a very narrow way, what soil it is. So, but it has an immense significance. So when we talk about sustainability and environmental health, soil is very much crucial for the environmental sustainability as well as the health of the people. It mitigates climate change, as I said, by storing the carbon, and soil's role in carbon sequestration and mitigating climate change is immense. It maintains the water quality and through filtration and recycling, and also it has a very good relationship between the healthy soil and clean water storage system. So I'll be talking something about the innovations in soil science. So what innovations are there in the field of soil science? We can use the modern technologies like GIS and soil sensors for precision agriculture, for precision farming. GIS is one of the integral part of mapping. So when is earlier session by professor was on the fertilizer biotechnology. So another applications of of the innovations in the field of soil science is the application of technological advances such as biofertilizer, uh, and microbes to improve the soil health. Also, we can go for the artificial intelligence, AI, and big data in predicting soil behavior and optimizing the land use. We also can go, these are some of the innovations, like even I'll be presenting in my case studies, success stories. So development of the soil museums is another part of innovations, because you can, with the museum, you can see the soil, you can see the types of the soil, the origin of the soil and everything, the characteristic, physical, chemical, and biological characteristic of the soil through soil museum. And you can, that gives certain, the soil of every locations you can get from the soil museums. And there, these days, everyone is more interested with the geopark, making some, park of the with the soils, and geoheritage areas are there with that also development of geoheritage areas, geoheritage sites that integrates with the culture, with the cultural integration, integrates with the culture of the area, what of the people living there. So these are some of the innovations that is done in the field of soil science. So the food security, and another part is the food security, that how food security is achieved through how that can be achieved through soil management. It can address the global hunger by improving the soil productivity of the soil. Where FAO has Food and Agriculture Organization of the United Nations has recently published one paper that remaining all the factors constant, if only the soil is managed, 58% of the production can be improved with the same management level. So, soil, if it is well managed, then 58% of the production can be increased. So that can be, that can secure the the food availability or food accessibility. So food security, in order to secure the food, in order to secure the production of the food crops, soil is pivotal, is very important. So another part is we need to bridge the gap between agricultural practice and innovations, or scientific research for efficient food production. Like we need to promote collaborative, platforms, like we can establish the partnership between farmers, scientists, and policy makers to exchange the knowledge. And we can create forums and workshops for direct communication and training. These are some of the areas, where we can bridge the gap between the current practices as well as the innovations what we have. And we need to strengthen the agricultural extension services. We can expand the extension services to deliver scientific findings directly to the farmers, as well as we can provide on-site demonstration of new tactics and technologies. We can integrate the technology like use of GIS, IoT, and precision agriculture to bring advanced scientific solutions to the farms. Also develop farmer-friendly mobile apps for the real-time information and on weather, pest, as well as crop health. And we can encourage participatory research, like involving the farmers in research projects to ensure practical relevance and adaptability. We can see that we can use their feedback to refine technologies for the local, conditions. We can disseminate. You can disseminate those knowledges, like use of radio, television, as well as social media to share the scientific findings with the farming communities. We can do that, and also we can translate those materials into local language for better accessibility. So these are some of the options how food security can be achieved through the soil management. So another case, as I said, I will be talking about the success stories, what we did, some of the case studies as well as success stories. So in Nepal, since I'm from Nepal, I'll be talking more on Nepal. So and that can be replicated. That can be maybe replicated, or you can also test there in your country as well, in India as well. So some of the areas like uh, uh, some of the hilly areas in India is also similar with Nepal. So you can pilot it in some of the areas. So community-based seed production initiatives was, it was done in one of the district. It is very near to Kathmandu area. So there, they focus on training the farmers on sustainable soil management practices for vegetable seed production, and that was one of the, one of the milestones in seed production sector, because when we got that good training, when the farmers got good training on the sustainable soil, soil management part, the seed production for the vegetables was increased manifold. That is why we generally say that in the case of soil, when we can if we manage well, then in that case the uh, production, productivity, as well as economy is it pushed up. And in Mustang, that is in the higher altitude, in the mountainous region, there we generally go for terrace farming. And in those areas, in those terraced farming, green marine crops, where farmers in the community level, they go for green marine crops, and in order to stabilize the soil, they did that, and though that was very famous, and that has made the soil more fertile, and that because of that, the crop production and productivity has increased 2 times. And another district, that is Mustang is in upper hills, I said. So in the middle, agroforestry in Sengza, this is also another district where farmers has planted my nitrogen fixing trees like Elnus nepalensis, and in between those trees they planted vegetable crops. So that was in the terrace riser, and that has also increased the production of vegetable crops. So vegetables, it was excellent, and the production was increased in one district, and that is one of the some of the success stories. And we also use biofertilizer for the soil health. In Nepal, because of the temperature, now it's 6 degrees now here in my room. So the lowest was 3 degrees today. But since I'm in the middle now, Kathmandu is in the middle area, but in the high hill, it's very cold. So in those areas, the biofertilizer do not work much. When biofertilizer or microorganisms are inactive in those areas, the mineralization process is very slow, and the crop growth as well as the crop performance is also slow, not good. It takes longer time, and in those areas when we started using biofertilizer, though we have in Nepal, the soil fertility is very good. The soil is very fertile because the organic matter content even in the Tarai region is 1%. In the mid hill is more than 2%. In the in the Tarai region it is 2%. In the plain areas, in the mid hills, 3%, and in the high mountainous area, in high hill and mountainous area, is more than 4%. So it's very, very good. And even in the when we talk about the total nitrogen, phosphorus, potash content is very high. But the thing is that though the soil fertility is very good, it has higher nutrient content, but yet what happens is that because of low activity or inactiveness of those microbial population in the soil, the availability of the nutrients is restricted in some of the cases. We see some deficiency in some of the areas, deficiency symptoms of even phosphorus, even potash in some of the areas. So that is another case. So when we use biofertilizer, so it increased the yield, and the fertility it regained. The microbial activity, population as well as the diversity increase, and that has changed the people's livelihood as well. So sometimes it increased the yield, and that has become very very success in those areas, in the mid hills. Again, in the eastern hills, mulching in ginger, generally mulching is done high thick, very thick mulching is done. And in those areas, what generally people do is double planting system of maize is done, because two double planting system, two plants in one spot. So two plants, and they keep a very big spacing. And when you keep more than 1 meter spacing, then in between those 1 meter space, you can go for ginger plantations. So ginger cultivation is done, and you never compromise. The farmer do not need to compromise. Any of those crops. Both, when that is planted as a sole, either maize or ginger, the yield of double planting system along with ginger is equivalent to that of sole crops, like sole crops of ginger, sole crops of tomato, maize. So if you combine those sole crops, then it's equivalent with that of a double planting system of maize, ginger as well as. So that has increased the income of the farmers in the eastern hills. So mulching has done a tremendous job in those areas. So there is another success stories. We has initiated Soil Champion Award, because we generally, what we do is we have done digital soil map of Nepal. So it is first in the South Asian countries. Our country has developed interactive digital soil map, and even India has done for some states or some districts, but not for the whole nation. India has WRB map, USDS soil classification map, but not the digital soil map. That is why when we do the updating work, every year we do updating of those digital soil map. And in that case, what we do is, from every province, we have 7 provinces and 77 districts. So those 7 provinces, we have provincial soil and fertilizer testing laboratory, and those those laboratories are responsible to collect the soil samples and analyze, and they give back to us those data, and we update every year. Every 2 years we used to update those. All the labs, from all those provincial labs, we get the data from every farmer, and we give them soil health card. Last year, we in 1 year we do 10,800. Last year only we collected and analyzed 10,800 soil samples. So from those 10,800 soil samples we collect for making the digital soil map, for updating those maps, from those samples, we select the best farmers and we award them as a Soil Champion Award. We give them award, and this award has sensitized people that if you maintain the soil fertility, if your soil is healthy, in that case, the government of Nepal is going to award us. So that is one of the awareness, one of the success stories that helps us to maintain the fertility of the soil, that encourage farmers to maintain the soil fertility as well as productivity. That is the case. So, and as I said, digital soil map of Nepal is one of the success stories in Southeast Asia. And that, in 2021, we launched the digital soil map of Nepal, and that in 2022 December, we updated it, and we have only 30,548 training data. That means the soil sample from each point data, and from that we prepared the map. Now we are updating every 2 years. So that map, if you want to visit, you can go to soil.narc, S-O-I-L, soil.narc.gov.np. And if you click in Google that, if you type soil.narc.gov.np in Google, that will give a website of National Soil Science Research Center, and you can select the province, you can select the district, you can select the municipality, you can select your own area. There are two maps. One is OpenStreetMap, the other one is Google Map. So from Google Map, you can easily locate your farmland or your area. So if you are interested with a very small area, then you can go for the point analysis. You can click the point and you just click that area. That gives you the status of your soil. What is the status? How much organic matter, pH, organic matter, texture, nitrogen, phosphorus, potassium, zinc, boron, everything it gives, parent materials, pH, So in that case, again, after that, there is another options where you can click what you have to do, which source of. So that is one of the success stories, as I said, one of the milestone we have done so far in Nepal in the field of soil science, and that has given that is visited by more than 130,000 users each every year. In the last year only, we have 129,000 visitors. They have visited the website and they have got the data. So, and that the accuracy is very good as well. It's 86% accurate when we validated those data, and it's very highly accurate. Accuracy is very high, and that has that can be utilized for specific site-specific nutrient management. There is fertilizer section. When you click again, that gives you which crop you are going to plant for the next season. Then after that, you will get uh, uh, if you are going to go for planting rice, then it gives you how much you have to go for, how much you have to give the farmyard manure or compost, how much zinc, how much per hectare or per kattha, is a very small unit of land, kattha, how much it gives you the accurate data. So that is one of the, milestones we achieved. So that is one of the success story I just wanted to share. So in the future directions, as I said, so there are emerging research areas in soil science, such as soil genomics, as well as the digital soil mapping. As I said earlier, also you can go for in India, digital soil mapping is done in a very small unit of land, like districts, up to district or state. Some of the states, I think Telangana has prepared, and I don't see for other states. So we can go for the soil genomics. Yeah. So these are some of the emerging research areas in the field of soil science, and educating or communicating communities. Communication is one of the other part where you have to, if you develop the sustainable soil management practices as well, if it is not well communicated with the farmer, it's quite difficult. Now, everybody, when the literate people talk, when we have a good platform, we just create this. See, this is Zoom talk, and I am from Nepal. We are linking together now here, but in Nepal, only 65% of the population is literate, and from 65% literate, only 10% are farmers. The soil science or agricultural technologies are for the farmers, for the smallholder farmers or for the entrepreneurs or for the large scale farmers. We are doing, everyone. Well, the technologies developed is for the farmers, for the benefit of the farm income, or for the farming community. So when 35% of the population are illiterate, in those cases, 98% are farmers. No, even, no farmer do not want his son to carry his own business in on profession. He doesn't want that his son, a farmer does not want that his son be a farmer again. He He wants that his son go for the white collar job. So, communicating those technologies or those information, whatever we derive, is another challenges what we have. So whatever, either it may be in the form of booklet, training, those communicating materials is not enough or not appropriate for the farmers. So communication is another challenges. Communication does not mean that when we have some information, sharing of the information from one to another is what we learned, that communication is the delivery of the information from informant to the receivers. But that is not only the communication, what I feel, because it is not that, is sharing of the feelings, sharing of the understandings. We must bring a common understanding. If you share it, there is always a miscommunication. So that is another part. So communicating with effective communicating is another part which we have to go in the future. So when we thought of soil science or soil conserving soil or others, we have to continuously advocate. Advocacy is another part. Advocacy for maybe for the collaborations, maybe, but for the restoration or for the conservation of the soil health, because this is the future. If you have good soil, if you can, hand over the good soil to the another generation, then they can, they can also produce good harvest, good yield in the future, so that they can survive. That is another part. That is why I say in the future directions, in the future way forward, we have to think of some of the emerging issues, researchable areas, and also communication is another part. Also the advocacy is another part. So, when we talk about the soil, responsibility is not only one's responsibility. Everyone has their own responsibility. Even the farmer has, policymaker has their own responsibility, scientist has, civil society, and everyone, they have their own responsibility. So everyone should be responsible to carry out those things, carry out each responsibility in order to conserve and maintain the soil health. That is one of another part. So in my summary, this is what I just wanted to summarize, highlight how the soil science is important in achieving the food security, or in achieving the sustainability of the environmental sustainability as well. So soil is the part of the solution of the global challenges. As I said, I have delivered so many global challenges regarding this food security, environmental sustainability. Then we talk about the climate change, then water security, then biodiversity conservation. All those things, can be solved, or that can, soil, if a healthy soil can be one of the options for mitigating all those challenges, for meeting those challenges. So, and another is the soil is the cornerstone for agriculture and environmental health, as I said earlier, as well. Sustainable practices such as regenerative agriculture, no-till farming, conservation agriculture, organic farming, these practices are very much essential for the long-term productivity as well as ecological balance. We have to, promote some of the conservation efforts as well. We need to raise the awareness about the soil health, and also continued advocacy is more important. Every time when we say, like Sadhguru, what he says, you just keep on saying what save soil, that gives you some of the energy, as well as it gives awareness to the people. So that is one of the thing what I also want to say, that we need to continuously go for advocacy. regarding the soil health. We have to do that. And this is my last slides. And just this slide says that there are no passengers on a spaceship Earth. We are all crew. Everyone is responsible. If the Earth or the soil is damaged, no, only one person who is not, or the only politician or the farmers are not responsible. All of us are equally responsible. So we are all crew. So everyone has the responsibility. We have to conserve the soil. So soil is the habitat for all. We must conserve it. So this is the end of my presentation. I just tried to, though I have only few slides, but I tried to, summarize the importance of soil. I said the power of the soil to what to say, to address all those global challenges. So thank you very much. Thank you for listening
Thank you,
to
sir.
me.
Wonderful
Thank
presentation,
you,
sir.
sir. Thank you, sir, for dedicating your time to sharing such valuable insights on this significant topic of the power of soil, advancing agriculture and sustainability through soil science, explaining how soil science derives sustainable agriculture, boosts productivity, and builds resilience to meet the challenges of food security and climate change. We now have some questions from our participants. Uh, our first question is from HR Dhanetya. Sir, what are the effects of urea and DAP on the microbial and earthworm population in soil?
Just a minute. What are the sorry?
Effect of what are the effects
Urea
of
and DAP on the microbial and earthworm population in soil. So DAP and urea, it's when we talk about the fertilization part, we must think of balancing the nutrients. Balanced fertilization is one part. You cannot, I always say that, only organic you cannot go, or you cannot go only inorganic. It should be balanced. If you can balance organic as well as inorganic nutrients, in that case you even the inorganic nutrients do not have side effect. That is well neutralized by those organic amendments. So if only urea is applied, in that case it increase the soil acidity. In that case, when soil acidity is increased, you can think that some of the microorganisms which are acidophiles, they exist. Others, the population goes on decreasing in those cases. But the thing is, population of the earthworm as well as microbes, microbial population and diversity with the chemicals, is negative. It decreases. But in our cases in Nepal, when I don't have that much idea on database. I don't have more on India, but I have database on Nepal. In that case, in Nepal, the fertilizers, mostly 95% of the fertilizer, we don't have our own chemical fertilizer plant in Nepal. So all the fertilizer requirement is made through import. So we import fertilizer from other countries like India, Bangladesh, as well as other countries. But what we do is only 5% of the total fertilizer imported in the country is supplied to the hills and mountains. So 24% of the total area in hills and mountain is by default organic, in our cases. So the population, as I said, because of the temperature, the mineralization process, it slowed down. It's not fast, but the population of the microbes, microbial population and diversity is very good. Very good. It is not in the decreasing trend, though there are few that in Tarai region, that is in the plain, I said, it's in the low altitude area where the temperature is also high, and the commercial farming or intensive farming system is followed in those areas because of low population of the cattle. Now everything has been shifted, has been, replaced by bullock, has been replaced by tractor. So bullock, it gives cattle dung. Tractor, it does not. Because of that, machineries, the population of the microbes has changed, but not because of those urea or DAP. DAP is another thing. It has not changed the earthworm population or microbial population, but because the machineries used in the Tarai region, in the plain areas, the population of earthworm has decreased. That is another part.
Thank you, sir. Sir,
Oh,
there another question. It's from Amra. Sir, does double planting system avoid use of biofertilizer? What is the main reason for going double planting system?
yeah, the double planting system, that is for doubling the income. In order to doubling the income, what generally the farmer do is they intercrop ginger in the with they intercrop in the with maize. So if single plant is planted, in that case the spacing or the because they maintain the number of populations around 66,000 per hectare of maize. So if we in between those plants, if the ginger is planted, in that case the bed is very narrow, is very small. So what they do is, what farmers practice is, they go for double planting and they give heavy fertilization. As I said, in ginger there is a very heavy mulching with organic manure, not with the others. Like mulching is not done by the plastics, with the organic manure or some of the litters collected from the forest. So they do very thick mulching. Then that mulch is converted to fertilizer, and that meets those things. So that is the reason why they go for double planting system, in order to maintain the population, as well as in order to get the double yield from maize as well as from the ginger.
Mm, Thank you, sir.
Yes.
Sir, there is one more question from HR Dhanitya. What is the mechanism of degradation of organic matter in soil? Do the microbes present in soil or soil itself degrades the organic matter?
Mechanism of degradation of organic matter in the soil. No, the organic matter, whenever you apply organic matter, organic is carbon containing materials. Carbon is the main food source for the organisms. So they degrade, but that do not mean that they degrade it, but that is again used by the plants as a source of fertilizer. Either is nitrogen or he's I think Dhanetya is talking about the organic matter only. So that is done by the soil microbes. And do the microbes present in soil, or soil itself degrades the organic matter? It, soil itself do not degrade. It's done by the microbes, but it depends. As I said, it depends the intensity of degradations or disintegration of those carbon. It depends upon temperature, rainfall, moisture, and there are other factors. Like for every 10-degree rise in temperature, the microbial activity doubles. So what if, as I said, in the mountain and high hilly areas, the organic carbon content is very high, I said, compared to the lower plain areas. That is not because of microbial population diversity more in the Tarai and less in the hills. That is not because of that. That is because of the temperature, as I said. So the microbes in the soil, they degrades the organic matter. That would.
Thank you, sir. Our next question is from Ajit Manade. Sir, how much time any soil take to convert itself from sterile to fertile at natural condition or vice versa?
This is a very good question and very tricky as well because it depends. It depends always because so when we talk about the soil forming factors, this has to be linked with the soil forming factors. Climate, CLORPT, what we DocuChip's, soil forming factors is when we consider the genus soil forming factors, CLO, climate, organism, R relief, P precipitation time. So how much time he's talking? It depends on climate. It depends on time. Time he's talking about time. So in natural condition, 1 centimeter of soil, 1 inch of soil, it takes 1,000 years to to develop naturally. You can think, but here when he's talking something about you know sterile soil to become fertile, dead soil to living soil. That means we generally say soil is living. So when it is dead, the soil has the lifespan of soil is 10,000 years. 10,000 years, the soil lifespan, it works till 10,000 years. But till that, what we get generally is 491 years in average. 491 years of the lifespan of the soil. Only 14% of the soil has more than 10,000 years lifespans. That is the forest soil. Agricultural soil, we generally have less than 600, 700 years because of the intensive farming, because of the intensive use of the chemicals, agrochemicals. So when we say about the under natural condition, that means if it is under forest, or we incorporate more organic carbon, in that case, if we can put more carbon, in that case it turns a bit rapidly, because with carbon, when there is carbon, the microbes, it automatically it comes. So within 5 to 6 years, we say 2 to 3 years if there is enough carbon. If not, then it takes more time. So if only few inoculums is given there, if you can inoculate few microorganisms, then it multiplies rapidly, provided there is enough carbon in the soil. So it depends on how much quantity of the carbon it has. It depends on that. But generally, it takes more than 2 years. In the first year itself, you cannot imagine, you cannot revive it. Next year, 2 years.
Thank you, sir. Sir, our next question is from Shivam Kumar Lal. Sir, what is the website for observing the nutrient content of various parts of Nepal?
Or is soil dot, I can message you here, soil dot narc, narc dot gov.np. I think at the end, I just soil.narc.gov.np. You can go with that. You can
Sir,
visit that website and you can see, you can go for the soil map. There are crop maps as well as soil maps. So you can go for soil map and you can see the, the nutrient content as well as the soil, everything you can see, all the soil parameters. That is our National Soil Information System of Nepal.
So, there's one last question from our participants. It's from Jyoti. Pesticide residues in soil is a major problem.
Mhm.
One individual pesticide residues in soil is a major problem. On individual level, what efforts can we do for its removal?
Oh, you know, you know, stopping pollution is the best solution. The best solution is stopping pollution. So when we go for pesticides residues, when we agrochemicals, if we apply agrochemicals, that means we are polluting the soil, or so we are polluting the environment. So if we stop the pollution, that is the best solution. So we have to every individual has to go for alternates. There are so many alternatives for the pesticides. Of course, I do, agree that in case of pest outbreak, the biopesticides or others cannot do much in those in that case. But others, you have to think of other alternatives as well, which we have, and we have to go for other like organic nature-based solutions. That is another aspect where how we can every individual can contribute on that aspect. Yeah.
Sir, there is one question from Amra. Sir,
Yeah.
can biochar be one of alternative for pesticides?
For pesticides, I don't believe, because biochar is not a pesticide. Is a soil conditioner. Generally, we say it's a soil conditioner. It's not a pesticide. But you know, in some cases, because it has high soil pH, so those bioagents or those pathogens which are very much sensitive with soil pH, soil alkaline medium, in those medium that can you can avoid those. They can escape the soil basicity of the soil. So in that case, I do believe, but it's not a alternative to pesticides. No, biochar is not an alternative for the pesticides. And another question is how can it be decided which plant or crop need which types of minerals, nutrients for the healthy growth? Yes, it depends. When we go for soil testing, the report of the soil test, it gives the different nutrient contents. After that, you have to set the every nation has their own criteria, own recommendation system. So in our cases, we have different ratings. One for Tarai, that is for plain, and one for the hills and mountainous area. So the rating is different. And when we think that the soil, there are the ratings, there are 5 ratings: very low, low, medium, high, very high. So supposing, let's think about organic carbon, organic matter. If it is very low, but the nitrogen content in the soil, phosphorus content, everything is high, but the organic matter content is low. In that case, you can go for organic sources of nutrients. You can go with compost or FIM. So it depends on the soil test report. You have to very minutely read those reports. You have to go between the lines. That is another case. Yeah.
Thank you once again, sir, for your engaging and insightful presentation and for addressing all the participants' queries. I'm certain that the participants have gained immense knowledge about the power of soil thanks to your extensive expertise. We deeply appreciate your generosity in sharing your profound knowledge with us and wish you continued success in your paths. Thank you, sir.
Thank you, sir.
Thank you, everyone. Namaskar, everyone. Thank you. Thank you for being with me for 1 hour. And thank you for the opportunity as well, because this is one of the opportunity given by AFTF and by Biotech Vital.
Vital Biotech, sir. Yeah.
Vital Biotech.
Yes.
Thank you. Thank you.
Thank you, sir.
As we conclude tonight's program, I would like to express my heartfelt gratitude to our esteemed presenters. Your sharp insights and extensive experience have been truly inspiring, enriching the knowledge of all participants. It has been an honor to learn from you. We extend our best wishes for your future endeavors. I also thank our participants for their attentiveness and active engagement throughout the day. On behalf of Vital Biotech, the Agriculture Forum for Technical Education of Farming Society, Kota, Indira Gandhi Krishi Vishwavidyalaya, Raipur, the University of Agricultural Sciences, Raichur, Karnataka, Atal Bihari Vajpayee Vishwavidyalaya, Bilaspur, Chhattisgarh, Farmers Park, Hyderabad, Telangana, and the entire organizing team, I deliver my heartfelt gratitude to esteemed guests, distinguished speakers, and enthusiastic participants for joining this 21 days winter school program. Your patience, active engagement, and attentiveness throughout the program have been truly admirable. Thank you once again for your invaluable contribution. Have a delightful evening. Thank you.